And all of the models that are making headlines, like the models that underlie Bard and ChatGPT, are um, uh, use the transformer architecture. In fact, GPT stands for Generative Pre-trained Transformer. And Transformer is an architecture that was published in 2017 by Google. And so the key part there to recognize is that was just 6 years ago. And the paper was something like all it takes is a little attention, and it uses a mechanism. It's actually a feature of the model called self-attention to produce output that is related to the input. So the input in this case, initially, it's the words that you generate that you submit to the model, and then it generates the first word of the response, and that's put into the input set, and it rescans that to generate the second word, and it puts that into and generates the third word. So the model is recursive. It generates the next word based on your input prompt and the response. The self-attention model has a mechanism for being dynamic in what it's attending to, but that's basically what it's doing. And the key thing to recognize about this is large transformer models are good at associating text strings. That's their claim to fame, is they can take a text string that you input, they can predict the text string that would be a good output for that input model, for that input string. And so, for example, I don't know if you could read this, but this is the OpenAI interface, and I typed in "every good boy deserves," and it answered fudge. So that's an example of it uh, uh, associating the input with the output. And what's actually happening in the background is a little bit complex. You type in "every good boy deserves," there's some processing that occurs, and it produces a distribution of possible outcomes, and it picks one. And we'll talk about that in just a second. What's most important about this graph or this slide is what's not happening, because people have misconceptions about how these models work. The internet is not being searched. No canned response is being found on the hard drive and retrieved and displayed. The model is not learning anything. You could think of this model as a really complex regression model. The input is "every good boy deserves," and the output is some probability distribution that it picks from. In the example I just showed you, it was fudge. For GPT-3, we can examine that probability distribution. And this is the probability distribution for "every good boy deserves." The output has about a 38% chance of it being fudge, about a 25% chance of it being favor, and there's several other possibilities. Obviously, this is a mnemonic for the treble scale, if you're wondering what a strange thing it is. And so you need an F word to complete the mnemonic. And I've always heard this as "every good boy deserves fudge." So I think it's right 38% of the time. My buddy Tom is a Moody Blues fan, and he knows about their album where the word is favor spelled the British way, and so that's the second most popular. It'd be right 24% of the time. The key thing to recognize is every time the model runs, every time you type in "every good boy deserves" and you send it off to the model is calculating this probability distribution, and then it's selecting at random from this probability distribution. It has a 38% of the time it picks fudge, 24% of the time favor, and so on and so forth. If you're familiar with the temperature parameter, I don't have time to talk about that, but that affects this probability distribution. That's the way that the temperature parameter works.